We saw in section 7.1 that there are tons of trig identities that relate all of our trig functions together. And in the next few sections of chapter 7, we're going to focus in on a few of the more useful of these identities. And we're going to start off today with sum and difference formulas. So we start off with sine of alpha plus beta. If you have a situation like this, you can't just distribute the sign over the addition as if it were multiplication. You have to use this sum formula, which is a little bit difficult to look at. So the first thing I want to do is just to verify that this formula actually works. It's not exactly intuitive that this would be the case. So I'm going to pick something really easy that we can verify with our unit circle. So I'm going to evaluate the sine of 30 degrees plus 90 degrees. All right, because those are two angles that I know the sine and cosine of by looking at my unit circle. I also know that the sine of 30 plus 90 is equal to the sine of 120. And looking at my unit circle, the sine of 120 is going to be the square root of 3 over 2. It's over there in quadrant 2. All right, so if I plug in 30 and 90 for alpha and beta in this formula, at the end, it should give me the square root of 3 over 2 if this formula is actually correct. So I'm just going to plug in 30 for alpha and 90 for beta on the right-hand side of this formula. So everywhere there's an alpha, I'm going to put a 30 degrees, and everywhere there's a beta, I'm going to put 90 degrees. All right, and then those are 4 trig functions that I know how to evaluate, right? So I'm going to go to my unit circle and say sine of 30 degrees is equal to 1/2. Cosine of 90 degrees, that's equal to 0 up at the top of my unit circle. Cosine of 30 degrees in the first quadrant, that's square root of 3 over 2. And sine of 90 degrees, again, back up at the top of my unit circle, is equal to 1. All right, and the formula says that I should multiply the first 2 and multiply the last 2 and then add in the middle. All right, so I get 1/2 times 0, which is 0, and root 3 over 2 times 1 added together, and I do get root 3 over 2. All right, so we've got the same answer that we got by just evaluating sine 120 straightforward. Nobody would evaluate sine of 120 degrees by using this formula. All I wanted to do was verify that it actually works. So not only do we have one of these beasts for sine alpha plus beta, we got one for sine of alpha minus beta, which looks exactly the same except for a negative in the middle instead of addition. And we also have one for cosine of alpha plus beta and alpha minus beta, which rearranges the sines and cosines a little bit. And nobody but your trig teacher has these memorized. And so you want to keep a running list of all of these identities that we're going to get in the next few sections of chapter 7 and have them on your cheat sheet for the exam. So most of the useful things that we can do with these sum and difference formulas are not things that we're ready to do quite yet at this point in a pre-calculus class. So most of the examples in this section and the next few sections are just kind of getting us used to these formulas and how they work. So one of the things that we can do at this point with these addition and subtraction formulas is find exact values of trig functions of angles that are not already on our unit circle. So 195 degrees is not on my unit circle, but I can use a cosine addition or subtraction formula to find the exact value. And again, exact value means the ones with the square roots in it and fractions and not decimals that come straight out of my calculator. So what I'm going to do for cosine 195, I'm going to rewrite 195 degrees as the sum of 2 angles that are on my unit circle. So I could take, let's see, how about 150 degrees plus 45 degrees. Okay, because 150 degrees and 45 degrees are on my unit circle. You could do 160 and 35, but I don't know what those cosine and sine values are. So we're going to stick with things that we know on the unit circle. All right, so I have cosine of addition. So I'm going to be looking down here at this formula. And I'm going to be using alpha equals 150 and beta equals 45. So this formula says to take the cosine of alpha, so cosine 150 times the cosine of beta, which is going to be cosine 45. The cosine addition formula has subtraction in the middle of it, kind of opposite of the sine function. So we need subtraction because we're adding, then sine alpha, cosine beta, no, sine beta. So just like the one I did with the sine addition formula, we're just going to evaluate these 4 trig functions using the unit circle. So I'm going to find the sine and cosine of 150 and of 45 degrees. So locate those 2 on your unit circle. Let's see, 150 degrees is over in quadrant 2, where cosine is negative. So you're going to find negative root 3 over 2. 45 is in quadrant 1. Cosine of 45 is root 2 over 2. Subtraction sign in the middle of the formula. Sine of 150 back to quadrant 2 is a positive 1/2. And sine of 45 in quadrant 1 is also root 2 over 2. Okay, so you got two terms. You're going to multiply, and then we'll put the subtraction in between. So when I multiply root 3 times root 2, the 3 and the 2 can go under one radical together and multiply. So you're going to get negative 6 under a radical over 4. And then we've got the subtraction, 1 times root 2 and 2 times 2. All right, so those are very spread out. They have a common denominator already, so I'm just going to subtract across the top. Negative root 6 minus root 2 over 4. All right, and the nice thing about these problems, I can go to my calculator and I can type that number in, negative root 6 minus root 2, and then divide that by 4. And I get negative 0.966 if I round that off. So then if I type in the cosine of 195, I'm in degree mode, so I'm going to type in cosine 195, and I get exactly the same decimal, negative 0.966. All right, so this is not an exact answer. This is not what the problem was looking for, but it is a reassuring thing that we can get the same answer as the calculator gives us for cosine 195.